Electromagnetic induction experiment. My experiment will allow me to scientifically observe magnetic fields made from the flowing of electricity. How current can be used to create a magnetic field? To be able to answer this question, the most important thing we need to do is start with the correct materials. The most important of those is the electrical conductor. In this case, copper seems to be the most conductive of the electrical conductors. So why is copper such an excellent conductor of electricity? Well, according to schoolscience.co.uk, the electrons can move freely through the metal. For this reason, they are known as free electrons. They are also known as conduction electrons, because they help copper to be a good conductor of heat and electricity. Copper Part 3. It is no wonder why I chose it to do my experiment, because there isn't much competition for copper and it is readily accessible and available in my city. The website goes on to say, copper wires allow electric current to flow without much loss of energy. This is why copper wires are used in mains cables in houses and underground, although overhead cables tend to be aluminum because it is less dense. However, where size rather than weight is important, copper is the best choice. Copper Part 2. Although silver is a better conductor than copper, it is also 10 times more expensive, so my best option is obviously copper. List courtesy of which Part 4. It is important to get and use the best materials so the outcome of the experiment will be clear and not bogged down by other variables. I got a toggle switch that will allow me to turn the current on and off as I please. Also a regular 2-inch nail made of wrought iron, along with batteries of various sizes, 7 in total, to see which battery caused the most powerful electromagnetic induction. The way I go about doing the experiment is probably the next most important thing. Do the experiment multiple times while recording all the data gathered during the course of the experiment. The independent variable will be the battery used at any given point, specifically the size of the battery and the toggle switch used to control the current. The dependent variable will be how magnetized the nail becomes, measured by the amount of paper clips the nail can pick up using electromagnetism. My constants will be the copper wire used in the nail, which is the subject to be magnetized. I will follow this procedure exactly to the letter. Cut a long length of wire and attached one end to the positive output of the toggle switch. Then twist the wire at least 50 times around the nail to create a solenoid. Once the wire has covered the nail, tape the wire to the negative terminal of the 9V battery. After that, cut a short piece of wire to connect the positive terminal of the battery to the negative terminal of the toggle switch. Turn on the switch. Bring paper clips close to the nail. What happens? How many paper clips can you pick up? Repeat the experiment with the 9V battery. Repeat the experiment with the rest of batteries I have at my disposal and chart the results like so. This technology can be used practically in a variety of applications. One of my favorites to read about was EMS, or electromagnetic suspension. The EMS system uses one set of electromagnets to float the train, and uses another set to propel it. In the EMS system, the entire track is connected to a large power source, which supplies the electromagnets. The sides of the track contain coils of wire, which make a strong electromagnet. This repels the magnets on the bottom of the train, causing it to float. Once the train is floating, the tracks uses a different system for forward motion. The coils are supplied with an alternating current, AC, which causes the coils to switch polarity. By spacing the coils with gaps, the train's magnets are first attracted to the magnets in front but later repelled by them as the train passes over. Part 2. Picture courtesy of Electropict 1 and 3. In conclusion, the current from the solenoid caused the nail to become magnetic. The magnetism does increase when the battery size is increased and hypothetically, but the size does not dictate the amount of power the battery puts out. According to my experiment, that is regulated in another way. Thank you for watching, and please, like and subscribe.